Carbon dating, the amount of radiocarbon present after T years is given by this formula in this box. Example 5, suppose that the skeleton of a woman who lived in the classical Greek period was discovered in 2005. Carbon-14 testing at that time determined that the skeleton contained 3/4 of the carbon-14 of a living woman of the same size. Estimate the year in which the Greek woman died. Okay, so that 3/4 is kind of important. That's how much she has right now, all right, and it's 3/4 of whatever she should have started with, okay? So that's kind of how we're going to deal with this problem, is we're going to take that formula, and instead of the y in the formula, we're going to plug in 3/4 of the starting amount. So 3/4 y0 equals y0 times e to the negative 0.00012116 t is what we're trying to find. That's my variable. So like a previous problem, you may notice that the y0s cancel out. So if 0.75 equals e to the negative 0.00012116 t. So you should know by now, to get rid of that e, we're going to take a natural log of both sides. So we want to do natural log of 0.75, that's the 3/4. We get about negative 0.2877 or so, equals negative 0.00012116 t. We keep doing kind of the same things. We're going to divide by that negative 0.00012116. So take that answer in your calculator, don't round, you're going to divide by negative 0.0001216, and we get 2365.8. T is approximately 2365.8 years. So that's how old this lady would be. So go back and look at the question. The question said, estimate the year in which she died. So they found her in 2005, it says, right? 2005. So 2005 minus 23, we'll call it 66. Negative 361. So we're going to call that 361 BC. Newton's law of cooling says that the rate at which a body cools is proportional to the difference C in temperature between the body and the environment around it. The temperature of the body at time t in appropriate units after being introduced into an environment having constant temperature is given by this formula right here, where C and K are constants. Newton's law of cooling also applies to warming. Example 6, Mary took a leg of lamb out of her refrigerator, which is set at 34 degrees Fahrenheit, and placed it in her oven, which she had preheated to 350 degrees Fahrenheit. After 1 hour, her meat thermometer registered 70 degrees Fahrenheit. A, write an equation to model the data. So C and K are constants. We're going to have to find C and K. So some of the things that are given to me in this problem, at time 0, we plug in 0, f of 0 is going to be 34 degrees. And after 1 hour, so time equals 1, f of 1 equals 70 degrees. So those are some things that we can use. The temperature to start with, so T0 of the lamb, I guess, is 350 degrees. So we're going to need all of that stuff, and here's what we're going to do. So let's find C. Go back and look back at the formula, f of t. So I'm going to start with f of 0. Plugging in 0 really helps me. So time, or temperature 0 right here was 350. Plus whatever C is, I don't know what that is yet, e to the negative k, I don't know what that is, but when I plug in 0, the time is 0. So some useful stuff is going to happen here when I plug in that 0. F of 0 is 34, equals 350 plus c times e to the negative k times 0 is just 0. So e to the 0, you should remember e to the 0 or anything to the 0 is 1. So I'm looking at 34 equals 350 plus c times 1 is c. So solving, I'm going to subtract that 350 over there and get c equals negative 316. So that's just a constant. Negative 316 degrees is a constant. Now I'm going to use that constant and find k. So we're going to use f of 1 this time. F of 1, so basically take that same formula we started with, and we're going to plug in 1 this time. Now t0 is still 350. That's not going to change. Plus c we just found was negative 316 times e to the negative k times 1. F of 1 was given to us as 70 equals 350 minus 316 times e to the negative k. So this is a little bit harder to solve, but we've got this. We've been doing this whole lesson. Subtract the 350 over, that's negative 280 equals negative 316 e to the negative k. We're going to need to divide by negative 316. Is about 0.886, let's say, is approximately equal e to the negative k. We should know by now to get out of that e, we're going to take a natural log. Take a natural log of both sides, so natural log of that answer, that way I don't have to round. Negative 0.12095, let's say, is approximately negative k. So divide by negative, that tells us that k is going to be about 0.12095. So we found k, we found c, we ought to be able to just plug those back into our formula there. So f of t is going to equal 350 was our starting amount, that doesn't change, minus 316, that was the c constant that we found, times e to the, now go back and look at this formula. Notice there is a negative sign. So put that negative in there and then put the k value, which was 0.12095 times t. Find the temperature 90 minutes after the leg of lamb was placed in the oven. Well, remember the formula that we had from before. 90 minutes, t equals 1.5 hours, so we're just going to plug in 1.5 into our formula. F of 1.5 equals 350 minus 316 times e to the negative 0.12095 times 1.5. About 86.4. degrees Fahrenheit. Part C, Mary wants to serve the leg of lamb rare, which requires an internal temperature of 145 degrees Fahrenheit. What's the total amount of time it will take to cook the leg of lamb? So we're going to use that same red formula from above, but the left side is going to be 145 degrees. So 145 equals 350 minus 316 e to the negative 0.12095 t. So solve the same way we have for a while. We're doing the exact same stuff. Subtract that 350 over, so 145 minus 350 is negative 205. We're going to need to divide by negative 316. about 0.6487. Seems like we keep doing the same things over and over again. Get rid of the e by taking a natural log of that answer. Negative 0.4327 or so is about equal to negative 0.12095 t. And lastly, we'll need to divide by negative 0.12095. Get about 3.58. T is about 3.58 hours. So that's maybe a little bit weird answer. You got 3.58 hours. That's not really how we talk. What is the total amount of time? 3.58 hours. But 0.58 times 60 would give us how many minutes it is. So maybe that's a little bit better. So about 3 hours and 35 minutes.